right. Hello and welcome everybody. Hello, Jesus. How is it going?
Hi, Alex. It's going very well, thank you. Good to be with you again. It's
Yeah.
first Tuesday in the month. Yeah, I was wondering, yeah, because I'm still getting familiar with the platform, but I
Yeah.
think my sound is coming all right, and video as well. So I suppose
Yes.
everything
Yeah. Looks good. Um,
perfect.
yeah. Welcome everybody. Good. Yeah. I keep saying good morning, good afternoon, good evening. I guess I continue to say this. So welcome to Going Meta episode 11. So yeah, last episode this year.
Right.
It's been a fun 10 episodes, and I'm sure episode number 11 will be a fun one again. So it's great to have you watch live on any channel really. Yeah, this is let's say a continuation, I guess, a little bit on what we started with episode 10 last month. We scratched a little bit on the surface of graph expectations, but then we couldn't really get to it. And Jesus, you
That's
said,
right.
okay, let's go for it in this episode, and yeah, do title it says it all, I guess. Better graph quality with graph expectations. So that's what we're going to do today. Yeah.
Exactly. Yeah. Yeah. Thanks, Alex. So yeah, that's the idea. I mean, as you probably know, this is a topic that's quite close to my heart. I'm particularly
Mm.
interested in being aware of the quality of our graph, which is something that I think we don't pay enough attention, and it's a very, very, very important one. And yeah, we've touched kind of from the sides in a couple of episodes, and in the last one, it was unclear whether. Well, maybe it was very clear that we were not going to have time to cover it all because we're all very optimistic, but yeah, we're going to take it where we left it then, and yes, the whole focus is on being able to understand to define metrics on the graph, to understand the quality, and basically to be able to inform the insights that we get. I mean, we're going to be using the graph for many different things, right?
Mm.
And we want to be sure that the quality of the data in the graph is is the expected one. And the way to do that is pretty straightforward. I mean, I have to say that at the moment that I'm aware of, there's not a way of doing that in a kind of how would I call it, like standard way. So
Uh-huh.
that was the intention with this kind of experiment, with this session today. So it's all about defining metrics that then we can monitor and we can track over time, and we can store, and we can see how the quality of the graph evolves as things change, because of course a graph is a live thing and we're going to update it over time, and these updates can have an impact on the quality. So that's the idea. That's the topic for today. And yeah, so as usual, I have a couple of slides to put things in context, and then we'll dive in and go straight to the code.
Sounds good. And while you are setting that up, again, as usual, this is live, this is interactive, this is meant to be conversational between you watching me trying my best to keep up, and Jesus being the expert um, on the matter. So if you have any questions, if anything comes around, you want to need another explanation maybe, or have an idea or something, I'm happy to obviously to read your messages out to Jesus. So just in case that gets missed, so don't worry if you have anything, if you see anything, if you wondering about anything, just type it in your uh, you know chat, whatever platform you're watching this on, and I should be able to see it. So that should be no problem for us to get conversation going. So that's definitely an open invitation. And yeah, here are your slides. Perfect.
Excellent. So Right. So, like I was saying, this is the topic of the day. So, being able to define metrics to measure the quality of the graph, and I'll give. I think I talked a little bit about it on the last episode. But the reason why I came up with that name is because I was seeing with a lot of interest what this company called Great Expectations are doing, and they've created exactly that. Is kind of a standard to monitor the data quality, but they work on tabular data. So they work on the what's called the modern data stack, which is essentially based on SQL, right? And they have a way of defining these metrics. Like, for example, the values in this column in this table have to be numeric, right? Don't expect to find any letter.
Hmm.
If they are, they have to be on that particular range. You cannot have negative values on stock level, for example, something like that, right? And like these, there's a number of more sophisticated expectations, as they call it. They call it great expectations, just like the novel. And I thought, well, should we try to apply this kind of approach, but to a graph, because
Yeah.
we don't have anything equivalent. So that was the starting point, and the idea with the name. So
There is a little equivalent, I guess, but it's not as thorough by looking at constraints.
that's a very good point. Yeah,
yeah,
and
yeah.
it's true, and you can define constraints, but the thing is, sometimes uh, I see constraints as a way of controlling the structure of the graph in a more kind of operational type of store scenario, right? So when
Yeah.
you own the data in the graph and you have an application that updates it and basically owns it. But what happens when the graph is the result of integrating data from different sources? And we've looked at, I mean, we've seen that in many episodes, right? When we collected data from Wikidata, what we load data from relational databases.
Mm.
So sometimes, I mean, you probably don't want to enforce these type of constraints because you understand that the data might be imperfect, but you still want to have it in the graph and then work your way through it. So totally agree with you. Uh, Constraints are very powerful tools, but I see them as kind of covering a different sort of area, if you want, in the quality data quality space. Does that make
Yeah, and
sense?
it's
Or
it's it's like more. I guess you can compare it. I mean, and we see about this, I guess, today. But so as far as I understand, constraints are more like how does your graph look like, and the graph expectations would be more like what is in your graph.
yeah, that's right. And the thing is, sometimes in the knowledge graph type of when you build a knowledge graph, you often bringing in data that was not designed. I mean, it comes from some other storage that was not designed for the use that you're giving it. So you kind of building
Mm.
something out of
Yeah.
data coming from different places. So each of them individually probably have their own constraints in their operational source, but we're kind of overlaying this. Sometimes people refer to this as kind of a semantic layer. So a number of metrics that determine what the expected shape of your data is. And that might sound familiar because if you remember when we talk about shapes, we had episode number 3, I believe, or 2, I can't remember, where we looked at Shackle for doing that. And I don't
Oh,
want
yeah.
to mention it, but Shackle is going to be under the hood on what we're doing today. So what we're doing is entirely Python based, as we're going to see. It's all, but but we're using Shackle and under the hood to basically to formalize, serialize, and exchange these constraints. So it's not entirely new content in a way, or something strange to our regular audience. So yeah, so like I say, we've created a Python library that's called Graph Expectations. At the moment, is in test mode, so we're going to see that we can do a pip install like you do with other modules, but you do it from the test environment, the test library, and essentially, we'll go in the details, but we'll show how to define the expected shapes of the elements in your graph, and the elements in your graph are essentially your nodes, your relationships, and how to actually verify that these shapes are complied with or not, and how to act on it. So yeah, let me go into the details of what that looks like. So the first element is the notion of a set of expectations, right? So we are going to instantiate and associate it with a category in our graph. And a category in our graph is a label, right? So it's a type. So we're going to say nodes of type company, like we see here, will have a number of expectations. So we create a set by doing that. Now we're going to see as well, and hopefully we'll have time towards the end, that we can sometimes define a shape that does not apply only to a node, a set of nodes defined by the label. That will be too restrictive. Sometimes you want to say, hey, I want to apply this shape to a subset of the nodes that's defined by a condition, whatever, a kind of a query, and that can be a cipher expression. So, for example, for anything in my graph that's connected to something else through a location or location city, I want to apply some constraint, or I want to define some expectation on these type of entities. So we can define sets based on queries, right? So that's the idea. So essentially, what we're going to do is define, that's the set of elements in the schema that this set of shapes apply to, this set of expectations, right? So once we've created a set, we're going to populate it with a number of expectations. We'll see that in a minute. But then we bundle them all in what we call a suite, right? So a suite is a collection of sets. So probably in our data set, in our graph, we'll have nodes of type customers, of type product, of type supplier. So I'll bundle them all in a suite, and a suite is a collection. I give it a name, and I give it sort of more a description, and it's just a collection of the expectations that I've created, right? The sets. And when I have it, the third step is to bind it to a database. So we create these in a kind of Python environment. In our case, we're going to be using a notebook. But eventually, we're going to have to say, okay, this set of expectations that I'm defining apply to this graph, and I'm going to bind it to a graph. And there's where, behind the scenes, and again, I'm not saying it, shackle is being exchanged with the graph. So I'm essentially serializing my expectations as shackle and deploying them in the graph. And I will use the usual way. I mean, I'll give my credentials to access the graph. And then I will be able to run this validation, to run these expectations that I've defined, and see the results. So that's the idea. But I want to go straight into the code, if that makes sense. And you tell me if that's readable. I'm going to make it a bit bigger.
I think a little, yes. Yeah, that's better. Yep.
Good. So this is already on our GitHub repository as usual. So feel free to, I mean, not right now. Now listen to me, but then you will be able to play it on your own. But
link
like
to the
repository
repositories in the video description. Yeah.
Right. So now I was saying if it makes sense so far, or any questions?
No question. It makes sense. Oh, well, maybe one question. When you say, but maybe I guess you come to it. When you say bind to a graph, you mean binding to a graph is you have a Neo4j instance running, and you say, okay, for this instance, this is
correct. And
yeah, okay.
and that is something that I've taken for granted, and I should have been more clear about it, because before we started this session, as usual, I went to my and thanks for reminding me, I went to my sandbox environment and I created a sandbox instance. I'm not going to show how we populate the graph, but you have examples even in episode 3 using the data import tool. So basically, I created a blank sandbox, and in the blank sandbox, I loaded the Northwind database. I'll show very briefly what the schema looks like, but it's the kind of very famous data set from it's from Microsoft, I believe, right? The one that came with the Access database and all those. But basically, it's a sales data set with products, suppliers, orders, customers. So this is my pre-populated sandbox. And like I said, if I call db schema visualization, we will see. And if I apply style, you go. So we see that our schema has three types of entities. So we have products that are supplied by suppliers. Products are organized in a category, and customers place orders that contain products. So pretty simple model, and we have just a thousand or so nodes in the graph. So that's the schema that we're going to be working with. So
Okay.
right, so let me start. So we can probably have a look at, let's start with the suppliers, right? So we see that the suppliers, we can get a bit of additional information about them. We can say, I'm going to return the properties of the suppliers that we call N, and that will give me an idea of what's in there. So a supplier has the supplier ID, the address, the phone, blah, blah, blah. And one thing that I've noticed exploring the data is that there are some anomalies on the country information. Let me show what I mean. So if I do an aggregate by country, so let's say something like n dot country, and I do a count of suppliers, and I order by supplier count, descending. And if I've made no mistakes, we see that most of the products come from, well, no, most of the suppliers are in the US, there's some in Germany, and so on and so forth. But if I scroll down, I find something a bit unexpected. There's a country, which is 0512. So the usual data quality issue, right? So this is clearly not a country ID. And if we and there's not many cases of that, but if we double click on that, you can imagine what's behind that, right? And I've taken and put the source data that populates this graph. It looks something like that. So it's a CSV file that I'm showing this in this spreadsheet, and you see that there's something very common, right? Let's look down here. So we have this line where probably the address had a comma, and then that shifts everything to the right. Is it readable?
It is. Yeah.
So, and there you go. So you end up with a region that's the city with the postal code, and something strange, and that happens a number of times. The moment, the problem with CSVs, right? So whenever you have commas and it's not properly escaped and so on and so forth, we find these kind of situations. Same here. And you end up with values in the country field that are probably the postcode or something that should have been a different thing. Anyway, data quality issues, right? So that's not what I want to see. And when that happens, I want to detect it. I want to pick it up, right, and be aware of it. So that's the first thing. I want to make sure that my countries are the country property on my nodes of type supplier have the right data type and the right values, if you want. So let's go to our notebook. And because, like I said, this is all Python environment, we'll have to, and this is purely temporary because we are running in this graph expectations library, still not deployed to the standard pip repository. It's on the test one, so we have to manually install the dependencies, which is neo4j, and I'm going to run that, and rdf lib. The moment this is ready to run the pip install normally, these dependencies will be managed automatically, and our graph expectations, when we install them, we would just need to do pip install graph expectations, and it will pull both neo4j and rdf lib without us having to be explicit about it. So that's it. So we have it installed. That was required. And we start, like we said before, by importing the two elements that we're going to, well, in this case, it's just the graph expectations. I'm going to be importing pandas just to present the output at the end, but we might as well do it now. So we import from graph expectations GE. And like we saw before, we are going to create a set of expectations. Remember that the set is a collection of expectations for a given type for suppliers. So I had that prepared already, and I've called it X, or we can be explicit and call it supplier expectations, whatever you prefer, right? So that's my set of expectations. So what am I going to put in there? So if I let the autocomplete work, we see that there's a number of expectations that are available for us, right, out of the box. And the one that I'm interested in is in defining the value of the property country, right? And I want to specify that this property, how could we express it? I mean, there's a number of ways. I mean, how do I say that I don't want my countries to have something that's not a proper country name? I mean, I could enumerate them, all the possible valid ones. It might be a bit overkill if I want to put all the countries in the world.
Yeah.
What I might say, in a simple way, let's use a regular expression. I mean, the value for that property has to be a string. It cannot have numeric values. There's no country that has a number in its name. So that would be at least an initial approximation. So we do have a regular expression expectation. So I can say I expect, I think there's a regex. So I expect my property values to match a particular regular expression. There you go. So that's the one I'm looking for. So that's my expectation. And all I have to do is provide the property. Right, so there is a property. I'm a bit impatient to wait for the autocomplete, but there you go. So the property that I want my expectation to apply to, we said that it was the country, right? And the name of the property was actually just country, like that. So if I type the name of the property, all I have to say is that the regular expression, and again, the autocomplete is showing me that the value that we need is regex. It has to validate a particular regular expression that we're going to express. Being the master in regular expressions that I am, I'm going to try not to make a mistake, but I want to say that my value has to be between, it has to be A to Z, either capital or lowercase, A to Z. And it can have at least one character. So that's those of you who are familiar with regular expression, what I'm saying there is it can be any string with more than at least one character, and the only valid characters are A to Z, either capital or lowercase. So that's my regular expression. So this is my first expectation. I expect my values to verify that, right? What else? Well, for example, I can think, I would expect also my products, or sorry, my suppliers, and let's go back here. If we take one supplier, to be connected to a number of products, because products are supplied by suppliers, right? So I don't know, we might say, okay, I expect my suppliers to be connected to at least, let's say a minimum, at least two, my provide at least two products, right? So that would be another data quality. Let's say that, maybe I'm making it up a little bit, but it's kind of a reasonable thing to expect, right? So I would say, okay, there's another supplier expectation. There you go. It's a bit slow, but I would expect relationship. There's a relationship, and it's actually an incoming relationship. So as you can see, there's outgoing and an incoming relationship, and I would expect the number of incoming relationships of a particular type to be between two values, right? And that's what I wanted to expect to express. So I can specify. I don't know if you see the autocomplete there, but that's it's a long name, but I hope it's at least even if it's verbose, it's very very intuitive. So I expect the number of incoming relationships to be between well, in this case, 2 and no upper limit, let's say. So again, I have to specify which relationship this applies to, and I hope the autocomplete will kick in. The relationship is going to be what was the incoming relationship? It was called supplied by. So we'll say this is supplied by, and I want the minimum to be, and as you can see, let's make that a bit more readable, because damn it, that's not very helpful, is it? Anyway, there's a min and a max. So the min value, we said it's going to be 2, right? So we expect that to be at least 2. We can specify a max, but or we can leave it empty. So we can say max has to be no more than 100 products, but whatever. Or we can leave it open, like I said, right? So that's another expectation. So these are my 2 expectations for suppliers, right? So one thing that I can do, and we're going to see that it's quite useful. I can give a custom message to each of the expectations. And that's I can use that to maybe give unique identifiers to my expectations. For example, let's say that's my rule number 1, and it's about the valid countries. Let's say I have a catalog of rules that I'm going to keep, and I have another one for this one message, and I'm going to say,
would this show up somewhere?
Exactly. That's what we're gonna show in a minute. And let's just say this is rule number 2, and it's about the minimum product supplier. I don't know, something like that. Okay, so I have my expectations for my suppliers, right? And if I execute that in my notebook, the next thing that I said, and I'll show in a minute how we can define more expectations, not only for my suppliers, but also for the products and for the customers and so on and so forth. But that's the idea, right? We create a set and we associate some expectations to the set. Once we have the set defined, what I'm going to do is I add the set to a suite, right? That's what I had prepared here. So I create a suite, again, from my GE central object. And I said, this is a suite of expectations for my Neo4j Northwind knowledge graph. And I add to these expectations, I add to this suite the expectations that I've defined. So if I run that, I have in S my suite. And I'll skip that for a minute. I'll get back to this.
But so you basically, you can order by creating various suites, you basically order by, like you did here. Okay, there's a suite for supplier, there's a suite for a user, correct. There's a suite for
actually let me do that, because I mean, in order to not be, because if I type, it's going to be quite slow. But let's say I'm going to copy paste another set of expectations, but this time for a product, right? So I define a set of expectations for a product. And I say that the number of property values for unit price has to be exactly 1. And with that, I'm saying something pretty obvious, right? A product can only have one price. So if we go to a product and we look, let me click products here and show you, you see that the product has a unit price and it's an atomic value. But let's say, for example, again, another of these quality issues, we end up having an array with 2 or 3 prices. What does that mean? I want to avoid that. I want that to be a single valued property, right? So that's exactly what I'm expressing with this expectation. I'm saying products for that particular property, I expect it to have exactly this number of property values between 1 and 1, or in other words, exactly 1. And I give it a rule name, which is single price. I'm also saying that the unit price has to be between 10 and 15 and 500. Or I could say it cannot be negative. I mean, you can think of it, right? In this case, I expect the property values to be between these and that. And I give it another name, right? So I have another expectation, another set of expectations, and I could add it to my suite, right? That's exactly what you were saying, right, Alex? So I will have as many as we need, and I will add them to my suite. So when I have it in my suite, let me run this. I have a suite containing the 2 sets at the moment. And then the next thing that we said in our
so now, description. Sorry, one question is: did you create now 2 suites, or is it 1 suite with?
Well, the terminology that I've used is I call this a set. So the set of expectations that apply to a category, to a label, I call it a set. Because it's a set of expectations, and then I group all the sets in a suite. So a suite is a collection of sets. And it's the one, a suite is something that I'm going to deploy to a database, that I'm going to apply to a data set. right? So
Yeah.
it's a way of kind of bundling them together.
Yeah.
Because then what
Okay.
I'm going to do once I have a suite is I'm going to say, okay, apply this suite, this collection of sets to that database. So that's what I'm going to be doing
Yeah.
next,
Yeah. Yeah. Yeah.
right? So my suite contains two sets, the set for suppliers and the set for products. And what I'm going to do is bind it to my database. And I have pretty conveniently there, if you're using Sandbox, you have the connection details here. So you have the URL and the password and the user. So that's exactly what I'm using here. So that's my URL, the user and the password. So all I have to do is bind, as I call it, to a DB. So what's happening behind the scenes, and that's what I was saying, is that this is deployed in the database and persisted in a way, right? So
Mm-hmm.
the next thing I'm going to do is run that. And again, I get back to the slides. I'm going to run that, and by that, what I mean is, okay, I want to verify the expectations in the data set that I've referred as the bound one, right? So, and that's what's going to happen here, except that instead of just producing the output raw, I'm going to populate a data frame with it. That's why we imported pandas before. So I'm going to put it in the data frame just for display purposes because it's going to look nicer, right? So
Mm-hmm.
what I'm doing essentially is running the validations and just printing out the results. So if that goes well, what I am going to receive is a table, and with
Mm-hmm.
all the list of violations of the expectations that I had defined. And back to your question, Alex, you see that we have in the column message to the right the ID of the rule that this particular violation applies to. So we have
I
exceptions
see.
because we
Yeah.
have what do we have here? So we have price limit issues. So we have products that are under $10, right? So that's, we defined that the product price had to be between 10 and 500. So these values are not acceptable. So we have a price limit um, issue here, an expectation issue. We have something, this is the minimum products per supplier. So we said that every supplier had to supply at least two products. So we have some cases where that's not verified, and we have all the information about the node here, right? And probably some more. We have some invalid countries, which is the one that we identified before. So you
Yeah.
remember the numeric values. There you go. So we have all detailed information on what's happened. So the exact node that's not complying with the expectations, which is the offending value, and what's exactly going on, and some kind of explanation, right? So that is something that I want to. I mean, I can do several things. I could act on that, or I could put it on a dashboard, something like that, right? So one thing I can do, and that's my final step here, I can group by, in this case, by message type, and maybe I can populate a simple dashboard here. Well, in this case, it's just a histogram, but basically showing me which expectations are being violated and in what number in my data set. So
Yeah.
does that make sense? I mean, let me take a pause here before we complete the example. Does that make sense?
That makes sense. Yeah. Yeah. It's very good. And you get with the dashboard. I mean, actually, that's quite. It's already like a. It gives you already insights in your data. I mean, this is first step of
Exactly.
saying, okay, what's where do I which pile of rubbish data, let's call it like this,
Exactly.
is what I'm
That's
going to tackle first. Yeah.
But that's extremely important because
Yeah.
one thing you can do the moment you have it in this format, you can define something like thresholds, right? So maybe a certain level is acceptable, but if you have above a particular number of issues, you might want to stop some downstream processing from taking place, right? If you're populating some
Yeah.
dashboards that you're producing, if you're triggering some actions out of the graph, hey, stop all that because the quality of the graph is compromised, and then try to find
Mhm.
out what's going on, right? So that's the idea. And I'm going to connect with, because we briefly, again, like I said, it's something that we've mentioned several times, and I'm going to bring another page, another slide. You might remember that because that was, I think there's a couple of episodes ago when we used this orchestration platform
I
to
remember this. Yes. Hmm.
Right. So, and there was this tiny thing where we were, I think we even talk about observability, because what happened here, if you remember, this was a knowledge graph that was populated from reading news from a couple of sources. I think it was the Financial Times, or the, I can't
Hmm.
remember which was the newspaper. So we were doing entity extraction, right? We were getting RDF, entity extraction, and populating the knowledge graph. So we kind of didn't knew really. And we even overlaid that with some information from Wikidata, with some ontology from Wikidata. So it was kind of a free data ingestion pipeline that could bring anything, right? Because I don't know what the news are going to be tomorrow. Maybe they're about energy. Probably there will be, or maybe
Yeah.
they're about football. There might be something about football as well. But what I mean is that I don't have much control on the knowledge graph that I'm building, right? But I'm running GDS. I'm running some analytics. I'm doing visualization on that. So is what I'm doing meaningful? I mean, is the quality here the one that's to be expected to consider the result of these analyses valid? So that's where we very, very briefly, you can, for anyone who's listening, you can go to that recording on YouTube and see how we mentioned that you can define metrics there. And we did persist them in I think it was SQLite or Postgres, because that's another thing. I mean, this is probably in our example is just a simple experiment, but this would be part of a data ingestion pipeline. So every time new data comes into the graph, I see this validation process taking place, and then we persist the output in maybe in a relational database, maybe, and we keep track over time of how these metrics evolve. So these kind of snapshot that we're seeing here right now in my graph, that's what's happening. But
Yeah.
maybe what I want to look at is what's the violations on the price limit evolution over time? Is it going up? Is it going down? I mean, that kind of time element is something that we can include as well in our analysis. So that's kind
Hmm.
of the context where you would see this element, these kind of graph expectations in a real scenario. Does that make sense?
It makes, yeah, yeah. And I think I guess it gives you always gives you two pathways. I mean, one is okay, you realize okay, your data that's coming in is not in a good quality format that you need it to be. Or on the other side, maybe you realize, because this example here, we said uh, one supplier needs to have at least two products. When you say, okay, that's what we established, but I realize now, because I don't know, 200 or so of my suppliers actually just have one product I'm selling because this is just what I have. Then my rules are a little bit too strict, maybe.
Yeah. Very, very, very good point. And actually, you touched there on a very, very interesting point, because are we looking at really data quality issues, or is there more like business semantics? Because
Hmm.
that's valid data, but the fact that maybe let's think a product is only supplied by one supplier, that's probably not a desirable situation. You want to make sure that every product is at least supplied by two suppliers, and that's
Yes.
something that we could express with that. But would that be data quality? I think this is more kind of business quality or business understanding of your domain. And that's
Yeah.
very, very powerful. And I'm going to touch on that very, very briefly, because that's what comes next. So this is kind of a mechanism to define metrics on your data. Some
Hmm.
of them will be probably more like the data types. I mean, it has to be a number. It cannot be negative. That's
Yeah.
probably more raw, more lower level. But as you go up, you can define really powerful metrics that have semantics, business value, and that you want to track that as well. So
Hmm.
yes, it's not just data quality. It's more than that. That's why I call it metrics, or well, not me. I mean, people call that kind of a metrics layer on top of your data, and that's why where it diverges a little bit from. You remember how when you mentioned before the constraints, is clearly a different space. So this is a
Yeah,
way of
absolutely. Yeah, yeah.
observe. It's called data observability. So you want to understand what's going on in your data to be able to make decisions, which is broader than just in an operational scenario, making sure that that every time you create a node, it has a primary or a unique identifier or something like that. So very, very good point, and I think that's really where the value is.
Yeah. Yeah.
So just to complete this example, I had a couple. I mean, I'm not going to type it, but I'm going to add just to mention let me paste them here. So I could keep going, right? And say, for example, let's just comment these. I'm going to define another set of expectations for customers, right? I hope it's readable here.
Yep.
And I'm going to say that, well, I could keep going, right? Like I would expect the properties, I'm going to delete that and just keep the others. But I'm going to say that customers, if you remember, they are connected to, let me show you very briefly, but if we look at a customer, actually, let me bring an order. So this is an order, and an order connects a customer that places the order with the product, right? So I want to make sure that when I analyze a customer, whenever there's a places relationship coming out of it, an outgoing places relationship, that connects it to an actual order, right? It doesn't connect it to a product or to a category. That would be wrong. Again, this is a good example of what's more lower level kind of data quality thing, right? I'm saying customers, I expect the outgoing relationship to connect nodes of type, so places, connects to orders. If that doesn't happen, it means it's a bad schema, and I can give it a name, right? That would be the more schema validity. I can also say something similar to what we did before. I want the number of outgoing relationships to be at least one. What do I mean by that? I expect customers to place at least one order. So maybe because of the way we work, you cannot create a customer in my sales data set unless there is an order associated with the customer. It's not a CRM, it's a sales data set. So maybe that has a meaning. I mean, it's data quality issue. So I'm saying there that I cannot have customers with no orders. So the minimum is one for the places kind of relationship. And that's another set of expectations for the customer. And just very briefly to touch on the one that I mentioned at the beginning, sometimes I want to have a bit more narrow, right? Not just, I mean, associating expectations to data types defined by labels is fine, right? I can mostly cover what I want to do, but sometimes I want to be more specific. And in this case, let's say I have some specific constraint for American products. What is an American product? I mean, there's not a definition of an American product in my database. An American product would be probably a product that is supplied by an American supplier. But again, there's not a notion of an American supplier. So it would be probably something like, let me type that. It would be a product supplied by a supplier where, let's call this as well. I could do it with a where, or I can inline it. I could say where the country is USA. So that would be the definition, right? So these would be an as American product. So that would be it. So these are the products that if I actually click, I mean, I don't want to click because all the orders are going to explode there. So that's not what I wanted. Let me actually rephrase. But you see what I'm doing, right, Alex? So let's put this in a path and return actually the path. There you go. So we have purple are the suppliers that are American, and we have products that I know they're American products because they're supplied by American suppliers, right? And there's no specific schema elements in the graph to say that. I have to use Cypher to kind of define this subset, but I still want to be able to define expectations for them. Let's say, for example, because I know that American products that come from American suppliers come from a particular inventory platform, they use a particular product ID numbering, something like that. I'm again making it up because it's a simple data set, but that's what I'm doing. So first of all, in this case, I define the set with a query, and instead of having a class like we had before, actually this is a node type. What I would be doing. Let me complete that. If you don't say, probably by default it takes it. But if you say it's a query, then what you mean is that there is a Cypher logic that identifies the set of nodes that this expectation applies to. And there's only one key thing. You have to use the keyword focus to refer to the selected node. So these are the nodes, the ones labeled focus to the ones that the expectation would apply. So in what I'm doing here is just taking the where, if you want, of of the of this cipher query. So I'm looking for products that have a supply by relationship, connecting them to a supplier that is in a country named USA, or in other words, our definition of American products. And for those, I want their product ID to be, I don't know, between 10 and let's call it max um, exclusive or inclusive, doesn't matter. It has to be an ID between, I don't know, between 10 and 200. Again, this is made up, but let's say I want to apply a particular expectation because the numbering of the American product should be that. So there you go. So that this is the kind of a type of metrics that I can define, and this is all described in terms of sets. So once I have them defined, we have to remember to add them to my suite. So now we have two: supplier, product, and we have to add customer and American products. So I extend my suite by adding the two new expectations and the usual process, right? I rebind it to my database. So in other words, I redeploy my expectations to the graph, and I run the validation. I call context run, and that would get me all the violations that probably are easier to analyze if I look at them in my chart. So I have a larger set of expectations, and again the usual information. So that's it. I wanted to. I mean, I don't know. Any question from your side, Alex? I want to just, before we move into the final couple of slides, to show that effectively, as we mentioned before, behind the scenes, what's happening is that all these expectations that I've defined in a probably more Pythonic and more as code, and I know we had this conversation on the title, but there's this infrastructure as code, metrics as code. So it's quite popular these days for people to define these things as if you were writing code. I mean, actually, you're effectively writing code. But behind the scenes, what's happening is that when we deploy that to the database, what we're doing is we're serializing that, and that's what happens behind the scenes. There's effectively a shackle serialization of that. So this is just, and again, that aligns with our vision, with the way we see RDF, right? It's a model for data exchange. So it's a perfect way to capturing, and shackle is the vocabulary that we use, these expectations, and we ship them to the database. But of course, if you are comfortable with shackle, you can always write that, and you're totally welcome. If you have an RDF editor and you want to write that, absolutely fine. This is, and again, the people who attended episode, I believe it was 3, right? We talked about
I think it was 3, yeah, early episode, yeah.
Exactly. So if that's your cup of tea, absolutely fine. You can express it. But I had the impression that people got a bit scared by, hey, do I have to write that? Well, if you want, you can. And there's a lot of detail, and I really invite you to watch that episode. But maybe you can use it as a way. I mentioned it here. Maybe to keep to version control your shapes, right? Maybe this is something that you want to put on GitHub, and I know that some of our customers are doing things like that, right? So you put it on GitHub and you keep track of it and see how it changes over time. You persist it somewhere, because of course this code is transient. I mean, this notebook is going to disappear when we finish this session, right? So there you go. So it's not only the way to exchange it and deploy it to the database, but it's also a way to persist it and keep track of it. So there you go. That's the kind of hidden language under the hood, and yeah, that's pretty much it. I hope it made sense. I wanted to conclude with a couple of slides, unless you have any question, Alex.
Yes, I had a question. So when this is basically more like an observational tool, instead of something that gives you okay, while while, let's say, an import or some kind of data pipeline is running, doesn't give you like error messages and says, hey, this is not in line with expectations, therefore I'm putting this on pause. Can you, let's say, I mean, very advanced, do you want to approve this or not? Or and this is more like afterwards you run it over your graph to check, okay, this this is not
Well,
what's in line with the expectations, please adjust.
the answer is both, right? And
I see.
again,
Okay.
I refer people to this episode where we looked at the orchestration of the data ingestion pipeline. So when you define the orchestration steps, one of your steps can be run the validation, check the results, and then it's up to you to decide if you're going to go forward or if you're going to trigger a different action. So you
I
can
see. Yeah,
absolutely.
yeah.
I mean,
Mm-hmm.
what you do with the results. Keep in mind that this is machine readable, right? This is the output. This is a summary of all the errors.
Okay. Yeah.
So you can define rules there where you say, if there's, let's say you want it to be perfect, right? So if there's a single error, you abort the execution and any further step
Mm-hmm.
is interrupted. Fine. If not, you want to maybe just update a database like we did here, and that will be tracked and someone will look at that and act on it, but I don't want to stop the process. So it's really entirely up to you. I mean, we used Prefect on that session, but any orchestration tool will let you make use of that in the way that makes sense to your case.
Yeah. Yeah.
So
Comment from Marek. Benefit of this versus doing the data quality before inserting the data to the DB, for example, in some APOC library. This is most post-processing data quality, isn't it? I guess. Yeah.
that's right. I
Yeah.
mean, yes. In this way of working, it is now, as we know, and again, we touched briefly on episode 3. Once you deploy, once you bind your expectations to a graph, you can enforce them as well, right? That's another powerful approach. So if you want
Mm-hmm.
to, again, it comes down to what your requirements are, right? Maybe you want to, let's get the data in, even if it's not perfect. And because I have my metrics, I'll know what's going on and I'll decide what to do. That's one approach, and fine. That would be, I won't interrupt the data ingestion. But you can also enforce it and say, hey, because my, some real-time processing that I cannot interrupt is taking place on my knowledge graph, I want to stop any write to the database that would introduce any inconsistency, any violation of my expectations. And you can enforce that too. So once the shapes, the expectations are deployed in the graph, you can activate a trigger. And again, that's both in the manual of Neo-Semantics and in episode 3, we talked about it. You can enforce it and stop any transaction from writing to the database, and literally your transactions will be rejected and will be you will be keeping your database in in a state of perfect quality, if you want, or at least
Mm-hmm.
according to your metrics. So both approaches are valid.
Cool.
And so just conscious of time, so wanted to very briefly, and some of these things we've talked about already. So the first thing is, of course, feedback. I mean, this is out there. I mean, the sandbox. I mean, sorry, not the sandbox. The notebook that I've used is already on our GitHub repository. So if you go to Argo in Meta, right, and which has an amazing collection of resources, as you can see, that's 11 chapters, 11
Mm-hmm.
episodes. All the code is here. So if you go to the 11th, you will find the notebook. So feel free to play with it, and it would be great if I could get some feedback, and of course it would be even better if we got contributions. The graph expectations is entirely open source. It is also in GitHub, and
Yes, let's maybe where would people, if people are having feedback, where would
I would
this
say, well, the
go?
repository is that's in Neo4j labs, and if we go to labs, you should see Oh no, that's not where. Sorry, I was confused. It's on my personal one. So it's in J Barasa, and there should be, if we look at all the repositories. Oh no, it's sorry, I'm completely lost. It's on labs. It's absolutely there. So uh, let me see, neo dash graph expectations. Here we go. So sorry about that. I'm too many repositories. There you go. So I'm going to
Yes.
paste. Shall I put it on the chat, or how do I do that?
I'll quickly. I think I find it
You know
in
what?
the
I'll put
under
it on
labs.
your.
Or if
I'll put it on Slack, and you can have it there.
yeah,
So
perfect. Yeah,
that's the
got it here.
repository. So I mean, this is just for the, if you want to push any issue or something like that. But in terms of using it, I mean, nothing should stop you. Just go ahead and run this pip install on your code. I mean, you can run this locally. It does not need to be on a on a notebook. I mean, if you have your PyCharm or VS Code or whatever your environment for development is, you can make sure that you import first Neo4j and RDF-lib, which are two prerequisites. And I mean, the moment that's ready, to get out of test, we'll make it public. But for now, just feel free to try it and apply. Create expectations to your data set, have them run, and yes, and give us ideas. Tell us what doesn't work. Tell us what's missing, and we'd love to use that to drive any further development there. So yeah, the other point on what's coming next is something that we're actively exploring already, and I was looking at a company in this space. It's not great expectations, but Monte Carlo, and they define observability as these 5 items, like freshness. Is your data fresh? Are you collecting data the expected rate? Are the values in your data distributed evenly? Is the volume correct? Is there a drop in the data volume for some reason? Because, again, keep in mind that this is the context of a continuous update of your knowledge graph. Is the schema correct? Is the lineage all right? So there's a number of elements that we want to monitor. At the moment, we've focused very much on the schema part. I mean, is the data correct according to that? Is to some extent the distribution of values, because we've checked that some values were in particular ranges. So there are areas that we're still not covering, but we are looking at extending specifically the distribution and the volume to cover that in graph expectations. So expect to see something along these lines, and we'll share more as soon as it's ready. And then the other part that I only briefly mentioned is, what do we do to include that in a data ingestion pipeline in terms of storing and integrating the result of this validation? And that's pretty much what we saw here. So how do we run the metrics and, for example, persist them in a Postgres database or whatever, so that I keep my historic of validation somewhere? So these are the 2 areas where we're being active, and that's what we should be talking. Probably not in the next one, because it would be too much about expectations and too much about. But I'm sure in the near future.
Further
But
down the line, yeah.
yeah, definitely would love to get feedback. That would be extremely valuable. So that's what I had for today. I think we're kind of running on time, so
On
not
time,
too
yeah.
bad.
Sorry,
But
I just saw the root X9 comment. Mind explain what this library is about. So you missed it, but you can watch it on as the VOD or on YouTube afterwards. So yeah, in brief, what we did is define expectations. So in terms of
some
how
metrics, some quality
metrics
metrics on the on the
exactly.
on the graph. Yeah.
Yeah, quality metrics on the graph. So what certain what values should be in certain fields, or how a schema should look like in terms of relationships outgoing or incoming from nodes to other nodes, and this would basically give you back a list of validations or faulty data in your
Mhm.
data in your graph that is existing, and you can check, okay, do you want to act on it or is it fine? and we showed an open source library how to do that, and that's what we did today. So if you're interested in this, basically rewind and watch.
And play with because it should be on
Yep.
GitHub. So feel free to go grab the notebook and run it and adapt it to your case and tell us what you think and tell us how it goes.
Yeah, that would be good. Yeah, I think that's great to finish on. I'd like to say thank you, Jesus, for presenting and for co-developing, I guess, graph expectations as well. I think it's really cool tool, and yeah, the invitation again open for feedback, for comments, for contributions. We will be back next month on I think the date we discussed was the 10th of January. So
because the first Tuesday was a bit too early in the year, right? It was kind of
the first one is the second
of
January. I don't think any 3rd of January, but nevertheless, it's too early in the year, so we push it back 1 week.
That's right.
Tomorrow, special episode, Learn with Jason Langsdorff, famously known from Learn with Jason. If you don't know, check out his YouTube channel. It's pretty cool. He's joining Adam Cowley, colleague of ours, to do a special episode on how to deploy Neo4j applications with Netlify. And next Tuesday at this spot, basically this time slot, I have Giuseppe from Laros out of Italy join me for an APOC library update. So if you're interested in APOC, in what it is, what it does, what it can do, what recent additions, join me then. And yeah, I think with that, thank you all for watching. Thank you for making this interactive again as usual, and thank you, Jesus, in particularly for presenting.
Well, thank you, Alex, and congratulations to us both for finishing, 11 episodes again.
11 episodes.
So yeah, here's to another 11 at least, so even more. But yeah, it's been great. I think it's a good end to the year.
Yeah, absolutely good fun. Hope you like it. If you do like it, give us a thumbs up on YouTube. Follow and subscribe. Obviously, Twitch or YouTube would be great to see some feedback on this one and all the other stuff we're doing. So yeah, with that, I guess see you around. It's not going to be the end of Going Meta, not the end of live streams for this year for sure. So we will be active until the very end.
Cool.
All right. Well then, take care, everybody, and see you soon.
Bye, Alex. Bye, everyone.
Bye, Jesus.